Okay, so we are looking at the PreAlgebra midterm practice test, and question 1 here asks us to evaluate 3 to the 4th power. So basically evaluate or simplify, or what is 3 to the 4th power? With our exponents, remember we're taking the base times itself, however many times our exponent is. So we have 3 times 3 times 3 times 3. Again, you can type this in your calculator, 3 times 3 times 3 times 3, or I know 3 times 3 is 9, this 3 times 3 is 9, and then simplify 9 times 9 to get 81. So 3 to the 4th power is 81. Question 2 is asking us to evaluate, we're doing the same thing, and to write our answer as a fraction in simplest form. So we have 2/5 to the 3rd power. So what I need to do is give 2 an exponent of 3 and 5 an exponent of 3. So 2 to the 3rd power over 5 to the 3rd power, which then if we continue to simplify this is 2 times 2 times 2 over 5 times 5 times 5. So then 2 times 2 times 2 is 8. 5 times 5 is 25, times 5 more is 125. And 8 does not go into 125. My factors of 8 are 1, 2, 4, and 8, and 125 is not divisible by any of those numbers. So 8 over 125 is the simplest form. Another way you could think of question 2 is if you look at, for example, if I have 4 to the 3rd power, what I'm saying is 4 times 4 times 4. So if I take 2/5 to the 3rd power, all I'm saying is 2/5 times 2/5 times 2/5. And when you multiply fractions together, so I'm multiplying the base times the exponent however many times. So in this case it would be 3 because I have an exponent of 3. I multiply my numerators straight across and my denominators straight across. So 2 times 2 times 2 still gives me 8, and 5 times 5 times 5 still gives me 125. So there's just 2 different ways to think about this problem. So question 3 asks us to rewrite using a single exponent. So this is our product of powers rule. So if they have the same base, if you look at those old exponent notes, you could just add your exponents right away. However, instead of memorizing all of those rules, what I can do is I can write this in expanded form. So right here in black, I have 4 to the 3rd power. So that's like saying 4 times 4 times 4. And then I can do the same thing with my 4 to the 6th power, which I can write in red, which is 6 fours. Then I can add them all together. I've got 3 in black, 6 in red to give me a final answer of 4 to the 9th power. Or I could have added my exponents from the beginning to get 4 to the 9th power. So it wants us to leave it in exponential form or rewrite using a single exponent. So that's how we get 4 to the 9th power. So question 4 is asking us to do the same thing, rewrite using a single exponent. And this is our power of a power rule. So my power has a power. If you remember from our notes, that's when we multiply our exponents together. So I'd say 7 and then 9 times 3 to get 7 to the 27th power. Again, I can write this in expanded form. So I could say 7 to the 9th times 7 to the 9th times 7 to the 9th, and then expand this and do 9 sevens, 9 sevens, and 9 sevens, and add those all together to get 27. But for lack of time, I'm not going to write it in expanded form and count all 27 up, but just if you struggle to remember the rules, break it down and write it in expanded form, and you'll come up with 7 to the 27th power. Question 5 is, again, we're rewriting using a single positive exponent. So this is the quotient of 2 powers, meaning we would subtract, saying 9 and then we would say 5 minus 2 being 9 to the third power. Or I can say, I'll write it in expanded form being 9 times 9 times 9 times 9 times 9 over 9 times 9. And then I would cancel out 2 from the top and 2 from the bottom, leaving me with 9 times 9 times 9, which we would rewrite as 9 to the third power. So when I go to cancel, I had a question on how do we cancel. Well, what I do is I cancel 1 from the top and then 1 from the bottom, and I do the same thing until I run out of things to cancel in my numerator and denominator. So in this case, I had 2 9s on my denominator, so I canceled 2 from the top and 2 from the bottom. So I'm left with 9 times 9 times 9 on the top. You keep canceling until you run out of either a number on the numerator or a number on the denominator. In this case, it was on the denominator. I ran out of 9s to cancel. I just had another question as to why we didn't cancel on question 2, rather than like we did on question 5. And we didn't cancel on question 2 because the bases weren't the same. You can only cancel when it's the same base. So I took a 9 for a 9 from the numerator and the denominator. I can't cancel on question 2 because I have 2's in the numerator and 5's in the denominator. So question 6 is asking me to add the following integers. The first one saying -5 plus -5, same sign, so my answer is definitely going to be negative. If I have 5 negatives and I add 5 more negatives to that, I have 10 negatives in all. And then if I look at questions, the second question, I have -4 plus 5. So if I'm in the hole $4 and I pay back 5, I'm ahead $1. Or I can ask myself, 1, 2, 3, 4 negatives, 5 positives. My negatives and positives cancel each other. Cancel, 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 cancel. Leaves me with 1 positive to get that 1. Question 7 is asking the same thing. So I have -51 plus -31. Both are the same sign, so I'm going to keep it as a negative number. And then I have 51 plus 31, which gives me 82, but a final answer of -82. And then the second one, I have opposite signs, so I have a negative and a positive. I'm going to go and ask myself, which one do I have more of? In this case, I have more positives, so I know my answer is going to be positive. And if you need to refer back to these rules, remember I gave you all that sheet of paper that had all the 4 operation rules on that, and I would go review under the addition section. Now, once I find the difference, or once I know I have more positives, I'm going to find the difference between the two. So I'm going to take my bigger number, which is 44, minus my smaller number, which is 26, and do some subtraction there. That leaves me with 18, and remember my answer is going to be positive because my bigger number was positive, so 18 is our final answer for this one. Next up on question 8, we have some subtraction problems. So these are where we start doing the keep, change, change. So if I have 5 minus 10, what I like to do is put my columns. I have keep, change, change, and then I'm going to rewrite it. 5 plus -10. In this case, I have more negatives than I do positives, so I know my answer is going to be negative. And I have 5 more negatives than I do positives, so I say 10 minus 5. That leaves me with 5 left over, and my answer is going to be negative. We're going to do the same thing with -9 minus 4. I like to draw my columns and do my keep, change, change in my columns, so I know -9, change the subtraction to addition, and the 4 needs to become negative. Now I'm adding 2 numbers with the same sign, so they're both negative, so I know my answer is going to be negative. And then I have -9 plus -4, so I'm in debt $9 and I spend another $4, so in all I'm in debt $13. or negative 13 would be my final answer. Question 9 is the same thing. So I have keep, change, change. Negative 3 plus positive 1. I'm in debt $3, but I pay back $1. I'm still in debt $2. Or you can do 1, 2, 3 negatives, 1 positive, cancel, leaves me with 2 negatives. Several different ways to think about this. Same thing with 6. Keep, change, change. 6 plus, that becomes addition, and my 7 becomes positive. 6 plus 7, nice and easy, gives me an answer of 13. Okay, so question 10 gives us a table, and the table gives the temperature in degrees Fahrenheit of 5 cities at 6 a.m. on the same day. Use the table to answer the questions. So we have San Diego, Miami, Memphis, Milwaukee, and Juneau. A asks us, how much higher was the 6 a.m. temperature in San Diego than Juneau? When it's asking how much higher, what it's asking is what's that difference between those two numbers. So Juneau was at negative 27, and San Diego was at 66. So I'm going to take my bigger number minus my smaller number to find the difference in those. So I'm going to take 66 minus negative 27. And if you think about it, think about your thermometer. Juneau, if here's the middle at 0, Juneau's down here at negative 27. San Diego's up here at 66. I have to find this distance from 66 to negative 27. Well, from 27 to 0, that's 27 degrees. And then 66, or from 0 to 66, that's 66 more degrees. So then I'll add those together. Or in this case, keep, change, change, which then changes it to addition, which is 66 plus positive 27. So when I add those together, I get 93 degrees. So San Diego was 93 degrees higher than Juneau. So for part A, if you're struggling with understanding to do subtraction, draw yourself a thermometer like I did over here on the right hand side. I have negative 27's Juneau, I keep in mind 0, and then I have my 66 for San Diego. So I need to find what from negative 27 to 66, how many degrees are in there in the middle. Well, from negative 27 to 0, I know I have 27. And then from 0 to 66, I know I have another 66. And then I just combine those two segments together, 66 plus 27, to get the 93 degrees as the difference. B then asks us, by noon, the temperature in Juneau has risen by 12 degrees. What was the temperature at noon? So I'm just taking negative 27 plus 12. And I know I have more negatives than positives, so I know my answer is going to be negative. But then I'm going to find the difference between the two. And I get 15, so my answer is going to be negative 15 degrees Fahrenheit. Question 11 is asking us to evaluate the following. So we're just taking, we're just doing the multiplication and division. When I have a negative times a negative, I know my answer is going to be positive. So question 11, again, we're multiplying and dividing integers. A little trick I had, remember, was make your little smiley face. So that way, in this case, I have a negative times a negative. So I'm going to circle those two, and I know my answer is going to be positive there. So negative 2 times negative 7, answer is going to be positive. Then I just say 2 times 7, that's 14. Then I can redraw my little smiley face for the second one if I forget. And in this case, I have a negative and a positive. So I'm going to circle a negative and a positive, and I'm left with just one negative, so I know my answer is going to be negative. 12 divided by 4 is 3. So my answer is negative 3 for the final. So question 12 is asking us to find each of the numbers below and simplify your answer as much as possible. So if I ask myself what's the opposite of -6, I know that's going to be +6. The opposite of 0, well, on the other side of the number line from 0, it's just going to be 0. And then I'm asking the opposite of the opposite of 5. So the opposite of 5, so my first opposite here is going to be -5. And then that opposite is going to be +5. So whenever you have the opposite of an opposite, it's always the number you start with. So questions 13 through 17 are going to be our order of operations number or problems. So remember, that's where we use PEMDAS. So if we have 10 divided by 5, or divided by the quantity of 5 minus 3, the first thing I'm going to ask myself, are there any parentheses? That's my P. Yes. I'm going to take 5 minus 3. I'm going to simplify that to a 2, and then I'm going to copy everything else down. So divided by, and then my 10. Then all I have left over is 10 divided by 2. That's 5. So my final answer here is 5. I'm going to do the same thing for 14. 39 minus 6 times 3. I'm going to ask myself, are there any parentheses? No. Any exponents? No. Any multiplication or division? Yes. Which comes first from left to right is my multiplication. 6 times 3. So I have 39 minus, and I have 18. Just replacing, substituting 18 for 6 times 3. And then now I just do my subtraction, 39 minus 18. Which leaves me with 21 as a final answer. I'm going to write problem 15 over here. I have 2 times 4 plus 7 minus 20 divided by 4. Again, I'm asking myself, any parentheses? Nope. Any exponents? Nope. Multiplication or division? Yes. Again, working from left to right. So in this case, 2 times 4 comes first. I replace that with an 8. And then I copy everything else down. So plus 7 minus 20 divided by 4. Then I go to that same step I just stopped with. Is there any more multiplication or division? Yes. 20 divided by 4. So I have 8 plus 7 minus 5. 20 divided by 4 is 5. And then now, any more multiplication or division? No. Now it's adding and subtracting, whichever comes first from left to right. 8 plus 7 is 15. Take away 5, 15, take away 5 leaves us with 10. And then lastly, we have problem 16. We're going to be taking 9 plus 3 squared times 7. Again, I'm working through PEMDAS, so I'm going to ask myself, are there any parentheses? No. Are there any exponents? Yes, and we'll stop there and we will simplify that. So 3 to the second power, that's 3 times 3, that gives me a 9. And then I copy everything else down with that. Then I go through and I go to that last step I was at, which is exponents, ask myself, are there any more? There's not. I move down. Is there any multiplication or division? Yes, I have multiplication right here. So then I have 9 plus 63, and then I just add 9 and 63 to get 72. So question 16, that answer is 72. Question 17 is also evaluating, so we're just using our order of operations again. So I have 88 minus 4 times 7 minus 3 squared plus 2 to the third power. So I'm going to ask myself, start at the top of my order of operations, which the first step is parentheses. I have parentheses here, so I have 7 minus 3. That gives us 4, and we're keeping that in the parentheses still and squaring that, and then adding everything else to it, copying everything else down. Then I ask myself, okay, any more parentheses? Yes, technically that 4 is in parentheses. However, those parentheses are used to multiply, so I kind of skipped that and I moved down to exponents. And I do have exponents. I have 2 different sets of exponents. I can essentially do both of those in the same step. So I have 16 and I have 4 to the second power, that's 16, and 2 to the third power is 2 times 2 times 2, so that's 8. And then I copy everything else down. After that, I ask myself, any more exponents? There's not. Now I'd move on to multiplication or division. Remember, when you have a number in parentheses next to another number, that's multiplication. So I have 4 times 16, that gives me 64, and then I copy everything else down. I don't see any more multiplication or division, so I move on to addition and subtraction, whichever comes first from left to right. In this case, my 88 minus 64 comes first. That gives me 24, carry down the plus 8, and then 24 plus 8 is 32. So our long expression right here, simplified all the way down to 32. Questions 18 and 19 ask us to simplify. We call this also combining like terms. If you look at 18, it's 8y minus 3y. I have 8 y's, I'm taking away 3 y's. I have 5 y's left over. 19 is doing the same thing, except I have subtraction here, so I'm going to keep, change, change. If you need to draw your columns, do that. This new problem, I keep my first number, negative 9a, change my subtraction to addition, and my 7a, that's why I put this line here, so I know that I need to change my 7a to a negative 7a. So I have a negative plus another negative gives me a negative answer. And then 7 plus 9 is 16. Don't forget your a's. They both have the same variable to the same power, so they are like terms, so they can be combined like that. Then our last question, question 20 here, says the table gives the increase in Kevin's account balance in dollars over 5 days. Changes in the balance only come from deposits or withdrawals. So essentially, if you look at each day, what it's saying is it's almost if you were to start each day with $0, because we don't know what Kevin started with. So all we're seeing is the subtraction being withdrawals. And if it's added, or a positive number, we will call that a deposit. Because again, it just is showing the increases and decreases in Kevin's account. We never know what actual amount he started with that week. So if we look at A, it says on which day was the most money withdrawn. So when we withdraw, I gotta go look at my negative numbers, because withdrawing, you're taking away from your account. So that I look at Monday and Tuesday and I say which one was more, and in this case it was Tuesday. B is the same thing, except it's depositing, so I'm gonna look at my positive numbers. So I'm gonna look at Thursday and Friday, and it looks like Thursday he deposited $2,871, so that is gonna be more than the 1,250. So Thursday is the day with the most money deposited. And then lastly, it says, what does it mean for Kevin's account when the balance to what did it mean for Kevin's account balance to increase by $0? Did it mean money was withdrawn that day, money was neither deposited nor withdrawn, or money was deposited? Well, if nothing happens, there's not positive or a negative. Remember, 0 is its own special number, that common ground in between our positive and our negatives. So that means nothing. There was no money deposited, and he didn't take out any money.